Welcome to the Solar Installation Training. In this course, we'll be exploring the fascinating world of solar energy, how it works, the components that make up a solar system, how to design and size solar installations, and how to maintain and troubleshoot them effectively. By the end of this training, you'll understand the technical concepts needed to design and install solar systems in real-world situations. Let's begin with the foundation. What exactly is solar energy? Solar energy is the radiation we receive from the sun. It can produce heat, trigger chemical reactions, or generate electricity. Now, there are two main ways we classify solar energy: solar thermal energy and solar photovoltaic energy. First, let's look at solar thermal energy. This is when sunlight is converted directly into heat. For example, imagine leaving a bucket of water outside in the sun for a few hours. The water becomes warm because it has absorbed the sun's radiation. That same principle is used in solar water heaters, which provide hot water for homes, and solar dryers, which farmers use to dry crops. The second and most important form for us is solar photovoltaic energy, often shortened to solar PV. This is the direct conversion of sunlight into electricity. The technology behind this is what powers solar streetlights, solar boreholes, and home solar systems. But how does this actually happen? It's thanks to something called the photoelectric effect. When light shines on certain materials, it excites their electrons. These electrons begin to move, and when we control that movement, we produce electricity. Now, here's a quick point to remember: the electricity that comes out of solar panels is called direct current, or DC. In DC, electrons flow steadily in one direction. But most of our home appliances use alternating current, or AC, where electrons change direction many times per second. Later in the training, we'll see how inverters convert DC into AC so that our appliances can run. Let's pause here for our first activity. Take a moment and think of one application of solar thermal energy you've seen. Maybe it's a solar water heater or a crop dryer. Now, think of one application of solar PV, perhaps a solar lantern, a solar-powered phone charger, or a solar borehole pump. If you're watching in a group, share your answers with each other. If you're watching alone, just say your examples out loud. Next, here's another question for you. What is the difference between alternating current and direct current? Take a moment to reflect on that. Direct current flows in one steady direction, while alternating current switches back and forth. This difference is very important in solar installations, as we'll see when we get to inverters. Great, now let's bring this together. Solar energy comes in two main forms: thermal and photovoltaic. Thermal systems give us heat, while PV systems give us electricity. The photoelectric effect makes PV possible, and understanding the difference between AC and DC will be crucial as we move forward. That wraps up our introduction to solar energy. In the next section, we'll dive deeper into solar photovoltaics, looking at solar cells, panel types, and the specifications you need to understand before designing a system.